The average American tiny house is 225 square feet. That includes the loft. That is the number nobody puts on a thumbnail, and it is what most people are actually buying when they buy small. Now hold that against a shape almost nobody in that market considers. A 24 by 40 steel arch is 960 square feet, and the shell kit for it lands near $12,500 less than what prefab tiny home shell kits start at. More than 4 times the floor, for less money on the shell. Here is the part I am not going to hide from you because it is real. This shape costs you floor space near the walls, and it costs you a meaningful amount. I am going to subtract every square foot of it, at the worst end of the range, before this video is halfway done. The claim still holds. That is why it is worth your time. Start with the definition, because tiny home is not a style or a philosophy. It is a legal size class. The International Residential Code defines a tiny house as a dwelling of 400 square feet or less, excluding lofts, that is, the ceiling. And the average American tiny house does not press against it. It sits at 225 square feet, loft included. Now the question almost nobody asks: why is that ceiling there at all? Follow each of these buildings back to the regulation that shaped it. The tiny home on wheels inherits highway law. To travel without special permits and escort vehicles, a load stays within 8 feet 6 inches of width and 13 feet 6 inches of height, and that height includes the trailer, the floor, the walls, and the roof together. Every tiny home on wheels ever built was designed inside that envelope before anybody drew a floor plan. The park model inherits recreational vehicle law. It caps at 399 square feet because at 400 it stops being an RV and becomes something the state regulates differently. The shipping container inherits maritime law. ISO standards fix it at 8 feet wide on the outside permanently, which leaves 7 feet 8 inches once you are inside the corrugated steel. A 20-footer gives you 160 square feet. A 40-footer gives you 320. There is no negotiating with that. And the lending system enforces the ceiling from above. FHA loans require a minimum of 400 square feet, so the entire category sits deliberately underneath the mortgage floor. Read that list again and notice what is missing. Not one of those constraints has anything to do with how a person actually lives in a room. Every one of these buildings was designed inside a box somebody else drew. There is one shape that never inherited a limit like that, and the reason is almost accidental. A Quonset arch is a series of corrugated steel panels bolted together into a curve. Each arch is self-supporting, and the panel does 3 jobs at once. It is the structure, the roof, and the walls simultaneously. There is no frame underneath, no interior columns, no load-bearing walls anywhere inside. That geometry matters for space, and I will come back to it. But the reason this building escaped the size limits has nothing to do with engineering. It is logistics. The kit ships flat, corrugated panels, pre-punched at the factory, stacked on 1 or 2 pallets, with a single type of bolt and an assembly manual. The finished building is assembled on your slab, which means the completed structure never had to travel down a highway in one piece. No highway width ever shaped it. No axle limit, no bridge clearance, no escort vehicle requirement. The 8'6" rule that quietly designed every tiny home on wheels in America simply never applied. So the dimensions come from the catalog rather than from the Department of Transportation. Widths run from 10 feet up to 100. Length extends in 2-foot increments by bolting on more sections, and suppliers state that length can run hundreds of feet without special engineering. Here is the practical consequence. If you want a wider building, you order a wider building. If you want a longer one, you add panels. Neither decision requires anyone's permission, a variance, or a redesign, and length in particular is close to linear in cost because you are duplicating a part the factory already makes. Compare that to a tiny home builder who cannot make the building an inch wider, no matter how much money you hand them. Now let us put actual numbers against each other. Take a 24 by 40 arch. 960 square feet on the plan, 1 story, 1 continuous open span. At the verified kit band of $6 to $20 per square foot, that shell lands around $12,500 depending on gauge, model, and supplier. Steel panels, bolts, manual, stamped engineered blueprints. Now the comparison, and I want to keep it fair by comparing shells to shells wherever the market lets me. Prefab tiny home kits sold as structural frameworks or weather-tight shells start around $10,000 for footprints legally capped at 400 square feet and averaging 225. Run the division at the cap, and that is $25 per square foot. Run it at the average, and it climbs past 40. So the arch shell costs roughly $2,500 more and delivers between 2 and 4 times the floor. For scale, the finished numbers. A completed tiny home averages $30,000 to $70,000 to build at $150 to $450 per square foot, with the national average sitting at $300 to $400. The container path runs similarly. A finished single 40-foot container home costs $25,000 to $80,000 for 320 square feet. Want more? 2 containers joined gives you 640 square feet at $70,000 to $120,000 because joining containers is structural surgery rather than addition. And the park model and the tiny home on wheels cannot enter this comparison at all. They are bound at $399 and $400 by definition. No amount of money buys the 500th square foot. 960 against 225. That is the plan-to-plan number. Now let me take it apart, because it is not the honest number yet. Now the subtraction, and I am doing it at the harshest end of the range rather than the friendliest. The curve costs you floor. On full radius arch models, the walls surrender roughly 25 to 30% of the floor area near the edges. Because where the steel comes down to meet the slab, it is leaning in over your feet. The plan calls that floor. A bookshelf calls it a wall it cannot sit flat against. A bed pushed to the edge loses its headboard to the sweep of the panel. So run it at the full 30% penalty, worst case, no mitigation. 960 square feet times 0.7 leaves 672. 672 genuinely usable square feet before you frame a single thing to recover any of it. Now hold that wounded number against the category it is competing with. The average American tiny house is 225 square feet. 672 is almost exactly 3 times that. It is also more than double the 320 square feet inside a 40-foot container, and it clears the entire 400 square foot legal ceiling of the tiny home class by a wide margin. The claim in the title survives its own worst measurement. Not comfortably, the word triple is doing exact work, and I chose it because that is where the arithmetic lands after the penalty rather than before it. And the penalty is treatable. Knee walls framed 12 to 18 inches inside the steel skin give you flat drywall, standard outlet placement, and normal door framing, which recovers usable wall at interior finish prices. Straight sidewall models cost roughly 10% more at the kit and hand the edges back from the start. Either way, you pay for it. I just wanted the number to be honest before you heard the good part. Because there is a second dimension nobody in this comparison ever counts. Every comparison in this market happens in two dimensions: floor plans, square feet, footprints. But nobody lives in a floor plan. You live in a volume. And the second measurement is where this stops being close. A 24-foot arch peaks around 12 feet at center. Go wider, and it climbs. A 30-foot arch reaches 15. Now run the same measurement across the category. A standard shipping container gives you 7 feet 10 inches of interior height. The high cube version buys you one more foot at 8 feet 10, and conversion guides recommend the high cube specifically because insulation, framing, and finishes eat into that headroom before you ever move in. The width is worse and permanent. 7 feet 8 inches, wall to wall, which means your floor plan is a corridor before you draw a single line on it. The tiny home on wheels has it harder still. Its total height must stay under 13 feet 6 inches, and that measurement includes the trailer, the floor deck, the walls, and the roof assembly together. Whatever remains is your interior. That is the entire reason the classic tiny home bedroom is a loft you crawl into rather than a room you stand in. Nobody stands up in a tiny home loft. You kneel by federal highway design. Under an arch, the geometry inverts. The curve overhead makes the volume read considerably larger than the square footage suggests, and the height costs you nothing extra. In conventional construction, a tall ceiling is an upgrade you pay for. Here it arrives as a consequence of the shape. And with no load-bearing walls anywhere inside, those 960 square feet arrange however you want them to. Bedrooms where you want them, not where the axle's allowed. So why does the small end of this market cost so much per square foot in the first place? The answer comes from the tiny home industry's own cost guides, and it is the most useful thing in this video. A tiny house still needs a full kitchen, a bathroom, an electrical panel, heating and cooling, water coming in and waste going out. Those systems cost roughly what they cost in any house, and then they get spread across 225 square feet. That is the entire explanation. The expensive parts of a house are not the walls. They are the systems and the fixed costs, and none of them shrink when the building does. The same rule governs the arch, working in your favor at 960 square feet and against you at 400. Freight costs what the truck costs. The engineering package is one number, whether the drawings describe 400 square feet or 1,200. The permit fee is largely indifferent to size. The end walls are required on every building regardless of how long it runs. Spread those fixed dollars across more floor and the rate drops. Concentrate them into fewer feet and it climbs. The published extremes make it concrete. A small 16 by 20 arch prices around $25 per square foot. A 10,000 square foot arch drops to around 10. Same product family, same steel, 2.5 times the unit price, and the only variable that changed was scale. So, here is the conclusion. Almost nobody reaches before the money is spent. Shrinking a home does not shrink its cost proportionally. It shrinks the floor and leaves most of the bill standing, which means the cheapest square foot available to you is almost never inside the smallest possible building. When you buy small, you are not economizing. You are buying at the worst rate the market offers. That said, tiny homes win 3 things outright, and the first one is not small. The first one is mobility. And it is genuinely valuable. A tiny home on wheels can be moved. If your county changes its rules, if a neighbor complicates your life, if the land situation falls apart, you hitch it and you go. An arch on a slab is permanent, permitted, and inspected. That permanence is an asset on a deed and a liability in a dispute, and only you know which of those matters more in your situation. The second is financing, and it is the one that decides things for a lot of people. Tiny homes on wheels with RVIA certification qualify for RV loans, and the industry has spent years building relationships with lenders who understand the product. Arches have not had that. Most conventional lenders decline them, and appraisers frequently classify a steel arch structure as agricultural or temporary rather than residential. Neither world touches FHA below 400 square feet, but one of them has workarounds and the other mostly does not. The third is raw unit price on a bare box, and it beats everything in this video. A used 40-foot shipping container runs $1,800 to $3,500 delivered as a weather-tight steel box. That is roughly $7 a square foot, about half the arch's shell rate. If 320 square feet is honestly all you need, the container wins this comparison on its own terms, and I am not going to pretend otherwise. The arch's advantage is contiguous scale. It was never the cheapest possible square foot, and one thing applies to every option here equally. The shell is not the home. Slab, insulation, systems, and interior are real money in all of these categories, and anybody quoting you a shell price as a house price is selling something. So here is where the title lands. Nothing in the tiny living market delivers this much contiguous enclosed floor for this money. 960 square feet on the plan, 672 after the harshest honest deduction, against a category whose average build is 225 and whose legal ceiling is 400. Triple, after subtracting everything that works against it. But I want to be precise about why, because it is not that the arch is clever, it is not better engineered than a tiny home, and the people building tiny homes are not worse at their jobs. The arch simply never had to fit down a highway. That is the whole advantage. Every other building in this comparison was designed inside a box drawn by somebody else. Highway width, bridge height, RV classification, maritime shipping standards. Those buildings are not badly designed. They are extremely well designed inside constraints that have nothing to do with living in a room. The arch got to skip that conversation because it ships flat and gets assembled where it stands. Here is what I want you to do before you compare any two housing options again, and it takes 5 minutes with a calculator. Convert both to dollars per usable square foot, not planned square foot usable. Subtract the curve on an arch. Subtract the loft you cannot stand up in on a tiny home. Then do it a second time for volume, because ceiling height is the dimension everybody forgets and nobody gets back later. Most people compare sticker prices, pick the smallest number, and never notice they just bought at the worst rate in the market. Run those two numbers on whatever you are considering and put them in the comments. I read them, and the spread is usually wider than people expect. Next time, how to buy back the floor space the curve takes, priced both ways, knee walls after the fact, or straight sidewalls from the start.